Now we've already talked about etc services and etc protocols as far as configuration files go. And we know that these two files are important in providing ports, protocols, and services information to other network configuration files and services. Now there are several other client and server services that are configured using several different files, and we'll go over a few of those files during this session. Now these files are actually dependent on each other. They generally don't stand alone, and together they all provide rules and configuration settings so that network communication can happen. Now some of the files that we'll talk about during this session include the etc hosts, etc host.allow, hosts.equiv, and we'll cover a little bit of Inet Decomp, although we're going to cover Inet Decomp a little more in depth in a later session. But see, these are some of the more important files that are out there that are required for both network communication and network security, and we'll go over a few of those now. One of the first files we'd like to go over in FreeBSD and Unix that we want to look at is the etc hosts. Now this etc host file basically is what we used before there was a DNS, or a domain name service. And essentially it contained mappings of IP addresses to internet host names. In order to do host name resolution, the computer would consult the host file. Now this is a little predated, it's deprecated. Machines really don't have to use host files anymore, and indeed in large networks it's basically impractical to use them. But on small networks you could still use host files, especially in cases where you don't have DNS, or you could use them to override DNS settings. So let's take a look at etc hosts, and basically you'll see that most of this file is commented out, although there's two entries that are important here. Notice the two entries that are not commented out: the ::1, that's the IP version 6 loopback address, and the 127.0.0.1. And as you know from basic networking, the 127 network is defined as the local host. And so we see this mapping here of 127.0.0.1, and it's mapped to localhost. And that's what we expect. When we type in localhost into an internet-enabled application, it resolves to 127.0.0.1. And notice the examples they give you through here about the imaginary network, and they talk about the RFC 1918 and private networks and so forth. So basically you could put your own entries in here, and you could actually map IP addresses to domains. For example, you can map a certain IP address to www.vtc.com if you liked, and then your computer would consult this file and use the information in it even over DNS. Whatever DNS said, the host file would take precedence normally. So this file is important because it helps name resolution in network communications. In any case, you can use the host file to replace DNS or in addition to it, but understand that the entries in the host file will override DNS entries. Another file we'd like to look at is the host.allow file. And what the host.allow file does for us is it allows us to basically specify which hosts are allowed and denied to access certain internet services or network services on the computer. Now previously you had a host.allow and a host.deny file, and you can still have that on certain Unix installations and Linux installations, but it's no longer necessary. The host deny file is deprecated. You can use the allow file and put both allow and deny rules in it. And the rules can be a little complex, especially when you talk about order of precedence and matching. But understand that basically all you need to know is you need to have an IP address or a host name, and you need to know what services it's allowed to access or not. And if you go through here, basically the file will explain how to change the entries for it depending upon what you want to do. For example, you have a sendmail entry here and localhost. That entry is not commented out near the top of the screen there, and that basically tells you that anything on localhost is allowed to access sendmail. Now you can have other IP addresses and protocols and so forth in this file, and basically it tells you which host is allowed to access which service. Inetd uses this, TCP Wrappers uses this, and some other services use host.allow as well. Another file that you may want to look at from time to time is a host.equiv file. You may or may not need this file simply because it's primarily used for our services. And our services are kind of a throwback to the old days. Basically our services such as remote copy, remote shell, and so forth were basically used for network communication. These have been largely replaced by secure shell and some other protocols because our services were not very secure at all. And they allowed probably too many hosts and too many usernames to access your system. It made it very easy to get around security and access the system. So you likely won't use or see our host except on older Unix implementations, but the host.equiv file is there to allow that, to facilitate access by hosts and users to the R services. Another file that we'll talk about a little bit later is the inetd.conf, and this is the file, the configuration file, that this inetd service uses to allow network services on the box. It's started up automatically and uses the inetd.conf file to start and to specify which services the box is going to run. And the inetd.conf file uses all the files that we've talked about so far, etc services, etc protocols, host.allow, and so forth, to enable these services and allow them to run. And in the next section, we'll talk about inetd and inetd.conf.